On the coast, vast container yards stretch as far as the eye can see, a sprawling city of steel boxes stacked high under the shadow of towering gantry cranes. These ports are hives of constant activity, the critical nodes through which the lifeblood of global commerce flows. Day and night, colossal container ships arrive from distant shores, queuing for their turn to unload thousands of boxes filled with goods. The machinery moves with relentless precision, lifting and shifting containers in a complex, non-stop ballet. From this vantage point, the system appears to be a model of modern efficiency, a testament to humanity's ability to orchestrate logistics on a planetary scale. It seems impossible that such a powerful engine of trade could ever falter. Yet just a few miles inland, a different and perplexing reality unfolds. Factory floors, which should be humming with the sound of production, have fallen quiet. Assembly lines have slowed to a crawl or stopped entirely, not for a lack of demand, but for a lack of essential parts. Small business owners check their inventory systems with growing anxiety, watching as stock levels dwindle without any sign of replenishment. Shelves in some retail stores begin to look sparse, with telltale gaps appearing where popular products once stood. This slowdown is not the result of a sudden economic crash or a collapse in consumer spending. Instead, it is a problem of connection, a strange and disruptive disconnect in the supply chain. The contradiction is stark and difficult to comprehend. How can the ports be overflowing with containers, operating at what seems to be maximum capacity, while the very industries that depend on them are simultaneously starved of materials? The goods are physically present, sitting in metal boxes just a short distance away, yet they remain inaccessible. The system designed to connect global supply and demand appears to be both full and broken at the same time. This paradox reveals a deep and often invisible fragility within the infrastructure that underpins our modern world, where a bottleneck in one small area can send shockwaves across the entire global economy, creating scarcity amidst abundance. This situation raises a fundamental question about the nature of global trade and the systems we have built to manage it. What are the underlying mechanics that allow a port, the symbol of logistical power, to become a point of failure? How can a yard stacked high with containers signal not strength, but a critical breakdown in flow? The answer is not simple. It lies deep within the intricate web of incentives, regulations, and physical constraints that govern these vital gateways. To understand why supply chains break even when ports are full, we must look beyond the surface and examine the hidden architecture of the system itself, a system that quietly runs the world until it doesn't. To understand how ports function, it is best to view them not as single entities, but as complex ecosystems. These systems are comprised of numerous independent actors, each with distinct roles. Port authorities act as landlords, overseeing strategic development. Private terminal operators lease the space and manage the day-to-day logistics of loading and unloading ships. Their primary customers are the global shipping lines, who decide which ports to call on. The ecosystem extends deep into the hinterland, involving customs agencies and the truck and rail carriers that connect the port to warehouses and factories. A port is a decentralized network where information must be shared and actions coordinated. The overall performance depends not on any single actor, but on the seamlessness of the handoffs between them. When this system slows down, attention often turns to immediate causes like bad weather, equipment failures, or labor disputes. However, framing these events as the root cause is an incomplete explanation. These events are merely triggers, stress tests that expose pre-existing vulnerabilities. A sudden demand shock, like the one during the pandemic, explains the timing of gridlock, but not the deeper reason. The core issue is that the system lacks flexibility. Economic models that prioritize cost minimization and just-in-time operations optimize for normal times, but make the system fragile in a crisis. The deeper drivers of port congestion lie in the system's internal logic, starting with a fundamental mismatch of incentives. Carriers prioritize vessel speed, terminals focus on throughput, and shippers demand low costs. These competing goals aren't aligned. For example, shippers' demand for low costs leads to megaships, which create massive arrival peaks that overwhelm terminals. This creates feedback loops. As container dwell time rises, yard congestion worsens, slowing down truck turnarounds and causing even longer dwell times. Another loop involves blank sailings. When carriers cancel port calls to avoid delays, the displaced cargo is rebooked on later vessels, creating surges that cause the very congestion they sought to avoid. A final driver is spatial constraint. Many ports are boxed in by geography with no room to expand. When cargo volumes grow, they must stack containers higher, reducing efficiency and compounding delays. The consequences of port dysfunction extend far beyond the terminal gates, creating ripple effects across the entire economy. To avoid stockouts, businesses hold more inventory, safety stock. Safety stock ties up capital. Those carrying costs are passed on to consumers as higher prices. More costs to move and store, higher shelf prices. When a major port becomes a bottleneck, cargo owners look for alternatives. Cargo may be diverted to smaller, less congested ports, or to ports on an entirely different coast. Smaller players feel the financial strain acutely. They have less leverage to negotiate with carriers and less capital to absorb unexpected costs. The effects of port congestion spill out onto public infrastructure. Roads leading to ports, packed with trucks, causing severe congestion for commuters. Businesses respond by fundamentally redesigning supply chain strategies, a focus on resilience and on risk management. The strategic pivot includes nearshoring and reshoring. Bringing production closer to home reduces transit times, lowers transportation costs, and gives greater control. As some ports become known for chronic congestion and others prove more resilient, investment and trade flows begin to shift. The environmental impact of port congestion is another critical system-wide effect. When ships are forced to wait for days at anchor, they often keep their main engines running, releasing significant amounts of greenhouse gases. On land, the long queues of trucks waiting to enter the port create concentrated pockets of air pollution, posing health risks to port workers and residents. We began with a paradox. A port yard overflowing with containers while nearby factories stood idle, starved of parts. Now the origins of this contradiction become clear. It is not the result of a single failure, but the emergent property of a complex system. The paradox of the full yet broken port is, therefore, the logical outcome of its own internal architecture. The intricate mechanics reveal a fundamental, unresolved tension. Throughput was prioritized over resilience. A resilient system requires buffers, extra yard space, surplus equipment, redundancy that the just-in-time, cost-obsessed model stripped away. The system is fast and cheap until it suddenly becomes slow and impossibly expensive. This forces a hard question. It's a trade-off between everyday low costs and protection against severe disruption. The answer will decide whether the paradox of the full and broken port keeps repeating. You've been watching System Atlas, exploring how the world's systems really work. Share your comments below. See you in our next episode.